one of the big questions in science is what's the origin of the whole shebang? You know, we live on a planet in a solar system that we think is about 4.5 billion years old. The early history, and that's the first, let's say, 10 to 100 million years of that history, is largely blocked from us. We can't see it on Earth. The oldest rocks that we can honestly get our hands on and say, yeah, with definitive proof this is bona fide old rock, is around 3.8 billion years old, with some suggestions that there are 4 billion year old rocks. So we have about 500 million years in there that we really don't understand. We can infer, but we use meteorites and things like that. But the more pieces of that early history we're able to look at and bring back, the better we understand how planets form. One of the big issues in planetary astronomy right now is, are there Earth-like planets out there? And we're using Kepler and Hubble and a variety of telescopes to look for them. But one of the basic things we don't understand and trying to understand is how solar systems form in the first place. How do you get hot Jupiters, for instance, big, enormous gas giants that orbit very close to their primary star? Why is our solar system so different from most of the ones we've seen so far? Those kinds of questions I think we can only get at by getting samples from the earliest history of the solar system, and asteroids in many cases present those samples. Those are the pieces of the early solar system. And we have to sort of wait for them to fall on Earth as meteorites, and it would be better, in fact, to go get one if you could. So.